So welcome to this latest video 162 Maths, and in this video we'll be going over the GCSE Maths higher topic of the equations of perpendicular lines. Now before we go through some past exam questions which will be included in as a link in the description below for you to have an attempt at, before watching this video I'll also go through generally all the concepts that you need to know to be able to answer these types of questions in an exam. Now before we get started working through some questions related to the equation and perpendicular lines, let's just have a quick overlook over some things that we need to revise and remember. Now the first thing is that perpendicular lines meet at a 90-degree angle, with one line having positive gradient and the other line having negative gradient. So this is really important to know so you understand what it is and what perpendicular actually means. Now, another question that's quite underrated when it comes to revision is proving when lines are perpendicular. Now, to prove lines are perpendicular, the key fact is that the product of the gradients of the two lines must equal 1. Now, another way of remembering that at GCSE level is the fact that one gradient is a negative reciprocal of another. But if you move on to A level, then this is the general proof to prove that lines are perpendicular, is if you show that the gradient of one line of line 1 multiplied by the gradient of line 2 is equal to -1. Now if you rearrange that, you will find that gradient of line 1 is equal to the negative reciprocal of the gradient of line 2, and the gradient of line 2 is equal to the negative reciprocal of the gradient of line 1. So if your teachers have told you that, they're not lying, they're not wrong. It's just something that's more used at GCSE, whereas at A level, what I've written here and what I highlight in pink is basically the general proof that lines are perpendicular. Now to find the equation of a line, you must either know one of two things. Now either you know the gradient and the y-intercept, and if you know the gradient and the y-intercept, then you can just use y equals mx plus c. However, what is becoming more apparent is when you know the gradient and the line, a coordinate that it passes through. And if you know that bit of information, then I would strongly recommend that rather than using y equals mx plus c, instead you use y minus y1 equals mx minus x1, where the gradient is m and the coordinate is x1, y1. Now other things to bear in mind is exactly what I've just said. So recognizing that the equation of a line is either y minus y1 equals mx minus x1, and again you use this when you know the gradient and a coordinate that the line passes through. Now if you know the gradient and the y-intercept, then I would strongly recommend that you use y equals mx plus c. So this tends to come into play when you've been given a diagram or a sketch of the line, and this is what you use when you've got no diagram. But again, you can use either or for when you have got a diagram. It's all up to personal preference choice. Now the next thing to remember is the gradient of a line. Now again, if you know two coordinates, or it's easier for you to find two coordinates, then I would strongly recommend using the formula of gradient equals y2 minus y1 over x2 minus x1. Now the key thing to remember that a lot of students mess up on when using this formula is recognizing that the y is at the top and x is at the bottom. Usually when students remember this, because they think of coordinates and they think x, y coordinates, they always think x goes first, y goes second, when actually it's the other way around. Now the official formula to work out the gradient of a line is the difference in y over the difference in x. Now if you remember that, then hopefully this formula should be second nature to you. Now again, another alternative to working out the gradient if you're given a graph is to draw a right angle triangle and recognize that the gradient is going to be the height of that triangle over the base of that triangle. And one thing that again that you need to remember if you are going to draw a triangle is don't forget the sign of your gradient. If your line is going up, then that's positive gradient, and if your line is going down, then it's negative gradient. So always remember to include the sign of your gradient. The next thing to remember is that parallel lines have the same gradient, and perpendicular lines, as already mentioned, when multiplied together equal -1, or if a line with a gradient of m is perpendicular to another line, then its gradient must be the negative reciprocal, -1 over m. Another key formula for you to remember when it comes to these questions is the formula to work out the midpoint between two coordinates. Now, to work out the midpoint between two coordinates, all you need to do is just add the x ordinates together, divide by 2, and then add the y ordinates, divide by 2, and you will have the midpoint between those two coordinates. Another key aspect of these particular questions is recognizing when lines cross the x-axis. Now, lines cross the x-axis when y equals 0. So again, all you need to do is to substitute y equals 0 into your equation, and you'll find where the points are where it crosses the x-axis. And similarly for where lines cross the y-axis, x equals 0. So again, if you want to work out where a line crosses the y-axis, just substitute x equals 0. So now let's have a look at some past exam questions. Now again, if you're wanting a copy of these questions, all you need to do is just simply click on the link in the description below, download the document, have a go at the questions, and let's see if you got your questions correct. So looking at question 1, it says circle the line that is parallel to y equals 2x plus 8. Now, one thing I forgot to mention, that when you're using y equals mx plus c, is you need to make sure y is the subject. So to read the gradient and y-intercept using y equals mx plus c, y must be the subject. And that's really, really important. So you might have to do some rearranging, but there you go. So looking at this particular question, we can see that our gradient is 2. So in all our 4 options, what I'm looking for is the coefficient of x, or the value that's in front of x when we've got y the subject. Now in each of our 4 options we have got y the subject, so I don't need to do any rearranging. It's just about looking at what number is in front of the x. So here I've got a half, so m equals a half. In the second option I've got minus 2. In the third option, actually this one does need a bit of rearranging, so that's going to be y equals 2x. So then I've got m equals 2. And in the fourth option I've got, well, if I just split that up, so I have y, and 8 divided by 2 is 4, x divided by 2 is a half, so m equals minus a half. So which line has a gradient of 2? Well, it's going to be the third option. And again, what I could say is, well, what I can spot is that the second option and the fourth equation are perpendicular lines, because one is a negative reciprocal of another, but also if I multiply those two answers together, I would get minus 1. For question 2, it says circle the line that is perpendicular to y equals 2x plus 8. So here m equals 2, so a perpendicular gradient would be minus a half. So I'm looking for which one's got minus a half. Now one thing I spot is that all the gradients, all the lines actually, the equation of lines, are exactly the same as in question 1. So this has got a gradient of a half, this has got a gradient of minus 2, this has got a gradient of 2, and this has got a gradient of a half. So looking at this, if I then do so I'm looking for where the gradient is minus a half, and that is actually, it's going to be option 4, because it should have been minus a half there. Moving on to question 3, it says A is 0, 4, B is 10, 9. Work out the coordinates of the midpoint of the line AB. So then using the formula of the midpoint, if I add the x ordinates together, so that's 0 plus 10, divide that by 2, and then add the y ordinates, which is 4 plus 9 divided by 2, and then work that out. So 10 divided by 2 is 5, 4 plus 9 is 13, divided by 2 is 6.5. So then the answer then is 5 and 6.5. For question 3b, it's asking me to work out the gradient of the line AB. So again, either I can recognise that m equals y2 minus y1 over x2 minus x1, in which if I use the coordinates of A and B, which is stated here. So A is 0, 4, and B was 10, 9. So here what I've got is I'm going to have 9 and 10 and 4 and 0. So it's going to be 5 over 10, which is a half. So M equals a positive half. And it is going to be positive because the line is going up. Now if I wanted to draw a triangle, then this point here is at 4, this point here is at 10, and this point here is at 0, and this point here is at 10, and that's at 9 rather. So then from this, what we can then do is we can then work out the base. So the base of that is 10, the height of it is 5, so again 5 divided by 10, the line's going up, so it's going to be positive gradient, so it's going to be positive of a half. Moving on to C, it says CD is perpendicular to line AB and passes through M. Work out the equation of line CD. Well, M has got a coordinate of, it was, if I remember, 5, 6.5. We know that the gradient, if it's perpendicular, is going to be the negative reciprocal minus 1 over of a half. And again, if you want to do the negative reciprocal of reciprocal of a fraction, just flip the fraction, so that becomes minus 2 over 1, which becomes minus 2. So then because I know one coordinate and I know the gradient, I can use y minus y1 equals mx minus x1. So here y minus 6.5 equals minus 2x minus 5. Then expanding the brackets, I get minus 2x plus 10. I then take the 6.5 over to the other side, so I have minus 2x plus 16.5. Moving on to question 4, it says the line AB has the equation of 5y equals 2x minus 3x. The line CD has the equation of 3y minus 5x plus 1. And the question is asking is A and B perpendicular to CD? Well, if I do a bit of rearranging with regards to this, so this then becomes y equals 2 over 5, so I'm dividing everything by 5, minus 3 over 5x. And if I rearrange this equation, I get y equals 5 over 3x plus 1 over 3. Now, if it's perpendicular, so if perpendicular, then the gradient of AB times the gradient of CD equals minus 1. Now the gradient of AB I worked out to be minus 3/5. So let me just zoom out so we can see all of that on screen. So the gradient is minus 3/5. And the gradient of CD is equal to 5/3. So if I then do 3 over 5 multiplied by 5 over 3, I end up with minus 15 over 15, which is minus 1. So yes, they are perpendicular. I think it's right. So as gradient of AB times the gradient of CD equals minus 1, they are perpendicular. So moving on to question 5, it says that AB and DC are parallel. Prove that ABCD is a parallelogram. Well, if it says that AB and DC are parallel, then what we need to do is if a parallelogram, then the gradient of, or DC, I should say, then AB is parallel to CB and AB is parallel to DC or CD. Now we know that this is true because it tells us. So this is fact. So the only thing that I've got to prove then is that AD is parallel to CB. So if I then work out the gradient of AD, so working out the gradient of AD, I'm going to use the formula of y2 minus y1 over x2 minus x1. So D is 2 minus 3 and A is minus 2 minus 5. So if I take them away, then what we end up with is 2 minus minus 2 is 4, and minus 3 minus minus 5 is 2, so that gives me a gradient of 2. Then if I work out the gradient of BC, then I've got C, which is 1, 4, B, which is minus 3, 2, and I take those two things away, I end up with 4 over 2, which equals 2. So as the gradient of AB equals the gradient of CD and the gradient of AD equals the gradient of BC, then ABCD is a parallelogram because you've got two sets of parallel lines. Then moving on to question 5b, so show that ABCD is not a rectangle. So what you've got to say is if not a rectangle, then gradient of AB times the gradient of AD is not equal to minus 1, because if it's a rectangle we have perpendicular lines. So if I then work out the gradient of AB, so the gradient of AB is minus 3, 2, and A is minus 2, minus 5. And if I take those two things away, I end up with minus 1 over 7. So then my two gradients are, let me just see what I've wrote down, AB and AD. So AD is 2, AB is minus 1 over 7. So minus 1 over 7 times the gradient of 2 is not equal to minus 1. So ABCD is not a rectangle. Moving on to question 6, it says the graph of y equals x is shown, and it says work out the equation of the line that is perpendicular to y equals x and passes through the point of 4, 4. Well, the gradient of this line is 1 because we've got 1x. So therefore the gradient of a perpendicular line is going to be minus 1 over 1, which is minus 1. So m equals minus 1 over 1. Now the coordinates of P is 4, 4. So then using y minus y1 equals mx minus x1, I know that these values here are my x1, y1, and this is my value of m. So then substituting that in, I get y minus 4 equals minus 1 x minus 4. Expand the brackets and I get y minus 4 equals minus 1x plus 4. Take the 4 over to the side, in which then I get y equals minus x plus 8, and there is my equation of a line that's perpendicular to y equals x and passes through point P. Moving on to question 7, it says line A has the equation of y equals 4x minus 3. Line B is perpendicular to line A and passes through the point of 8, 3. Work out the coordinates of the point where B intersects the x-axis. So first things first, what we need to do is recognise that the gradient of line A has a gradient of 4. Now in order to work out line B, what I need to do is work out the equation of line B. Now the facts I know is that the gradient is going to be the negative reciprocal of the gradient of line A, which is minus a quarter, and it passes through A3. So then using y minus y1 equals mx minus x1, I get y minus 3 equals minus a quarter x minus 8. Then if I expand the brackets, I get y minus 3 equals minus a quarter x, and then a quarter minus 8 is going to be plus 2, and then rearranging this, I get y equals minus a quarter x plus 5. Let's just put a little bubble around that. Now, as mentioned at the start of the video, where it crosses the x-axis, it crosses the x-axis, or the y, the x-axis, not the y-axis. So the x-axis when y equals 0. So if I substitute y equals 0 into this, I get 0 equals minus a quarter x plus 5. Take the 5 over, so minus 5 equals minus a quarter x. Now another way of writing that is minus 5 equals x over minus 4. If I take the minus 4 over, minus 4 times 5 becomes positive 20. So my coordinate then is 20 and 0. Moving on to our last question, it says that ACB is a straight line. A is at the point of 0, 8, and B is the point at 4, 0. C is the midpoint of AB. The line DCE is perpendicular to the line ACB. Work out the equation of line DCE. So in order to do this, what I need to do is I need to work out a couple of things. So I need to work out the gradient of AB, and I need to work out the midpoint of AB. Now to work out the gradient, all I've got to do, here I've got a triangle, so I could use y2 minus y1 over x2 minus x1, but basically I've got m equals 8 over 4. Now because the line's going down, it's going to be negative, so that's going to be minus 2. So that means the gradient of DCE is going to be the negative reciprocal, so it's going to be positive a half. So let's just put a little box around that. Then the next thing for me then to do is to work out the midpoint. So the midpoint of AB is where I add the x ordinates. Well, half of 4 is 2, and half of 8 is 4. So C is going to be at the coordinate of 2, 4. So then using y minus y1 equals mx minus x1, I can then use C and use the gradient to work out the equation of DCE. So the equation of DCE is going to equal y minus 4 equals a half x minus 2. So then expanding the brackets, I get half x minus 1, and then taking the 4 over, I get y equals a half x, and it's going to be plus 3. And there is my final answer.